Test planning and estimation. Purpose and content of a test plan. A test plan outlines test activities for development and maintenance projects. Planning is influenced by the test policy and test strategy of the organization, the development life cycles and methods being used, see Section 2.1, the scope of testing, objectives, risks, constraints, criticality, testability, and the availability of resources. As the project and test planning progress, more information becomes available and more detail can be included in the test plan. Test planning is a continuous activity and is performed throughout the product's lifecycle. Note that the product's lifecycle may extend beyond a project scope to include the maintenance phase. Feedback from test activities should be used to recognize changing risks so that planning can be adjusted. Planning may be documented in a master test plan and in separate test plans for test levels, such as system testing and acceptance testing, or for separate test types, such as usability testing and performance testing. Test planning activities may include the following, and some of these may be documented in a test plan. 1. Determining the scope, objectives, and risks of testing. 2. Defining the overall approach of testing. 3. Integrating and coordinating the test activities into the software lifecycle activities. 4. Making decisions about what to test, the people and other resources required to perform the various test activities, and how test activities will be carried out. 5. Scheduling of test analysis, design, implementation, execution, and evaluation activities, either on particular dates, e.g., in sequential development, or in the context of each iteration, e.g., in iterative development. 6. Selecting metrics for test monitoring and control. 7. Budgeting for the test activities. 8. Determining the level of detail and structure for test documentation, e.g., by providing templates or example documents. The content of test plans vary, and can extend beyond the topics identified above. A sample test plan structure and a sample test plan can be found in ISO standard, ISO IEC, IEEE 29119-3. Test strategy and test approach. A test strategy provides a generalized description of the test process, usually at the product or organizational level. Common types of test strategies include: 1. Analytical. This type of test strategy is based on an analysis of some factor, e.g., requirement or risk. 1. Risk-based testing is an example of an analytical approach, where tests are designed and prioritized based on the level of risk. 2. Model-based. In this type of test strategy, tests are designed based on some model of some required aspect of the product, such as a function, a business process, an internal structure, or a non-functional characteristic, e.g., reliability. 2. Examples of such models include business process models, state models, and reliability growth models. Important quality characteristics are company-wide look and feel standards for mobile apps or web pages. 1. Process compliant, or standard compliant. This type of test strategy involves analyzing, designing, and implementing tests based on external rules and standards, such as those specified by industry-specific standards, by process documentation, by the rigorous identification and use of the test basis, or by any process or standard imposed on or by the organization. 2. Directed, or consultative. This type of test strategy is driven primarily by the advice, guidance, or instructions of stakeholders, business domain experts, or technology experts, who may be outside the test team or outside the organization itself. 3. Regression averse. This type of test strategy is motivated by a desire to avoid regression of existing capabilities. 3. This test strategy includes reuse of existing testware, especially test cases and test data, extensive automation of regression tests, and standard test suites. 4. Reactive. In this type of test strategy, testing is reactive to the component or system being tested, and the events occurring during test execution, rather than being pre-planned, as the preceding strategies are. 4. Tests are designed and implemented, and may immediately be executed in response to knowledge gained from prior test results. 4. Exploratory testing is a common technique employed in reactive strategies. An appropriate test strategy is often created by combining several of these types of test strategies. For example, risk-based testing, an analytical strategy, can be combined with exploratory testing, a reactive strategy. They complement each other and may achieve more effective testing when used together. While the test strategy provides a generalized description of the test process, the test approach tailors the test strategy for a particular project or release. The test approach is the starting point for selecting the test techniques, test levels, and test types, and for defining the entry criteria and exit criteria, or definition of ready and definition of done, respectively. The tailoring of the strategy is based on decisions made in relation to the complexity and goals of the project, the type of product being developed, and product risk analysis. The selected approach depends on the context and may consider factors such as risks, safety, available resources and skills, technology, the nature of the system, e.g., custom-built versus COTS, test objectives, and regulations. Entry criteria and exit criteria, definition of ready and definition of done. In order to exercise effective control over the quality of the software, and of the testing, it is advisable to have criteria which define when a given test activity should start and when the activity is complete. Entry criteria, more typically called definition of ready in agile development, define the preconditions for undertaking a given test activity. If entry criteria are not met, it is likely that the activity will prove more difficult, more time-consuming, more costly, and more risky. Exit criteria, more typically called definition of done in agile development, define what conditions must be achieved in order to declare a test level or a set of tests completed. Entry and exit criteria should be defined for each test level and test type, and will differ based on the test objectives. Typical entry criteria include 1. Availability of testable requirements, user stories and/or models, e.g., when following a model-based testing strategy. 3. Availability of test environment. 4. Availability of necessary test tools. 5. Availability of test data and other necessary resources. Typical exit criteria include 6. Planned tests have been executed. 7. The defined level of coverage, e.g., of requirements, user stories, acceptance criteria, risks, code, has been achieved. 8. The number of unresolved defects is within an agreed limit. 9. The number of estimated remaining defects is sufficiently low. 10. The evaluated levels of reliability, performance efficiency, usability, security, and other relevant quality characteristics are sufficient. Even without exit criteria being satisfied, it is also common for test activities to be curtailed due to the budget being expended, the scheduled time being completed, and/or pressure to bring the product to market. It can be acceptable to end testing under such circumstances, if the project stakeholders and business owners have reviewed and accepted the risk to go live without further testing. Test execution schedule. Once the various test cases and test procedures are produced, with some test procedures potentially automated, and assembled into test suites, the test suites can be arranged in a test execution schedule that defines the order in which they are to be run. The test execution schedule should take into account such factors as prioritization, dependencies, confirmation tests, regression tests, and the most efficient sequence for executing the tests. Ideally, test cases would be ordered to run based on their priority levels, usually by executing the test cases with the highest priority first. However, this practice may not work if the test cases have dependencies or the features being tested have dependencies. If a test case with a higher priority is dependent on a test case with a lower priority, the lower priority test case must be executed first. Similarly, if there are dependencies across test cases, they must be ordered appropriately regardless of their relative priorities. Confirmation and regression tests must be prioritized as well, based on the importance of rapid feedback on changes, but here again dependencies may apply. In some cases, various sequences of tests are possible, with differing levels of efficiency associated with those sequences. In such cases, trade-offs between efficiency of test execution versus adherence to prioritization must be made. Factors influencing the test effort. Test effort estimation involves predicting the amount of test-related work that will be needed in order to meet the objectives of the testing for a particular project, release, or iteration. Factors influencing the test effort may include characteristics of the product, characteristics of the development process, characteristics of the people, and the test results, as shown below. Product characteristics. 1. The risks associated with the product. 2. The quality of the test basis. 4. The complexity of the product domain. 5. The requirements for quality characteristics, e.g., security, reliability. 6. The required level of detail for test documentation. 7. Requirements for legal and regulatory compliance. Development process characteristics. 1. The stability and maturity of the organization. 2. The development model in use. 3. The test approach. 4. The tools used. 5. The test process. 6. Time pressure. People characteristics. 1. The skills and experience of the people involved, especially with similar projects and products, e.g., domain knowledge. 2. Team cohesion and leadership. Test results. 1. The number and severity of defects found. 2. The amount of rework required. Test estimation techniques. There are a number of estimation techniques used to determine the effort required for adequate testing. Two of the most commonly used techniques are: 1. The metrics-based technique, estimating the test effort based on metrics of former similar projects, or based on typical values. 2. The expert-based technique, estimating the test effort based on the experience of the owners of the testing tasks or by experts. For example, in Agile development, burn-down charts are examples of the metrics-based approach, as effort remaining is being captured and reported, and is then used to feed into the team's velocity to determine the amount of work the team can do in the next iteration. Whereas planning poker is an example of the expert-based approach, as team members are estimating the effort to deliver a feature based on their experience, ISTQBCTFL at. Within sequential projects, defect removal models are examples of the metrics-based approach, where volumes of defects and time to remove them are captured and reported, which then provides a basis for estimating future projects of a similar nature. Whereas the wideband Delphi estimation technique is an example of the expert-based approach, in which a group of experts provides estimates based on their experience, ISTQBCTALTM. Key takeaways. 1. Test planning is a continuous activity that outlines the test activities for a development or maintenance project, taking into consideration factors such as the test policy, development lifecycle, objectives, risks, and resources. 2. Test strategy provides a generalized description of the test process at a product or organizational level, and test approach tailors the strategy to a particular project or release. 3. Entry criteria and exit criteria define when a test activity should start and when it is complete, and are a means of exercising effective control over the quality of the software and testing.